Unit 1, Lesson 4, and in this particular video we are going to discuss the price of a car in a particular year. Let's get started. So the first thing I want you to do is I want you to clear the RAM by hitting second, the plus sign, and 712. Now it says a new car was purchased in 1995 for $18,500. The Kelley Blue Book value of the vehicle for each year after that is listed in the table below. Use the linear regression capabilities on a graphing device to create an equation that models this data. So it specifically shares with us we're going to use the linear regression capabilities. The first thing we're going to do is we're going to plug in the given information. Time will always be the X value, and when it goes into your calculator, it goes underneath the L1 category. And in this particular problem, the price or value of the vehicle will be in the L2, representing the Y's. So we're going to start by finding the stat key and pressing stat, and we're going to edit it. Now I've taken already time to put these in so I can have a shorter video. I would like you to press pause. Again, L1 will always be your X's and L2 will be your Y's. So make sure to look those over, press pause, enter, and then come back to this video. All right, hopefully you've had a chance to plug these in. Now, what we're going to do is we're going to take these points and we are going to graph a line that is not exactly the average of those points, but it models the data as approximately as possible. So what I want you to do right now is I want you to go to Stat and Calculate. And in this particular problem, it's already told us that we are going to use a linear regression model. So I'm going to go down to number 4, find the Enter key in the bottom right, and continue to press Enter. This is going to help us to create an equation that models this data. What I want us to do next is I want to exactly take this and copy and paste it into this particular graph. So go up to y equals. Now how do we take that exact answer and plug it in here? Well, to do this, if you have not learned, you're first going to go to VARS. VARS is located right here underneath the arrow. And we're going to go down to statistics, which is number 5. We're going to go over to EQ, which stands for equation. And now this is going to take the regression equation that we just created, and it's going to copy it and paste it in there. So now I have an equation, a linear equation. We also need to fit the window like we've learned to do in our previous lesson. So please go zoom 0, which is zoom fit. This will provide us an approximation of the price of the car. Now, it would be interesting to see where are the data points that represent when the car was first purchased in year 2000, the beginning of 1995 for $18,500, or after 1 year of owning the car, it's now worth $1,600. Well, we can find those points. We want to go up to stat plot, so hit the second button and hit y equals, and we want to turn this on. So I'm going to hit enter twice until the on button is on, and then I'm going to hit graph. So these are the exact data points, and this is an approximation. And what I learned in going through AP instructors training this summer, that it's really important when we answer these questions to always put approximately, because this line is an approximation. It's not a guarantee that when we make a prediction in the future based on this regression model that it's going to be exactly that answer. Let's get started. All right, first question. Again, if the car was purchased January 1st, 1995, and it was worth $18,500, how much will it be worth in January 1st, 2003? So remember, we're provided with a time, an X value, and we want to know the corresponding Y value. How do we figure that out? Go second trace value, and I'm going to go, and I can see they're both January 1st, okay? So it's going to be from 2003, the larger of the two numbers, 2003, subtract 1995. This is the original year the car was purchased, and we want to know what is the value of the car from the beginning of 2003, knowing that it was purchased in the beginning of 1995. We press enter, and this would be our answer. So we can assume that would be worth approximately, and that word approximately is really key, and I learned that this summer. So the value of the car in January 1st, 2003 is approximately $6,482, and we'll round to the nearest cents in 14 cents. Let's go on to the next problem. Very similar. I'd like you to press pause, do this problem, and then come back to the video. In this question, it says how much will the value of the vehicle be? January 1st, 2005. So again, second trace value. I'll put in the larger of the two numbers, 2005 minus 1995. I don't need to worry about the dates because it's January 1st to January 1st. And we can see the approximate value of the car will be $3,529.76. Now, it is very important that we use the word approximately because this is a linear regression that approximates the values. It's not a guarantee. How many days and years did it take for the vehicle to drop to 5,000? So when it discusses up above in the table, when it discusses the value of the vehicle, notice how that's the Y. Time is always X. So we know the value, the Y value is 5,000. Go to Y equals, go down to Y sub 2, and let's type in 5,000. Press graph. In class today, we learned how to solve systems using the intersection key on a graphing calculator. I want to know, when is the value of the car 5,000? I want to know that intersection value. I can find that by going second trace and down to intersect, pressing enter, 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 and we come up with this time frame. So what does this mean? What does this mean? So the car's value will be I forgot to press enter, will be 5,000 at approximately 9.0040325, but it says it wants answers in terms of years and days. So I'm going to take a time if I can figure out how to do this here, and I know it's going to be 9 years because that's the whole number here. Now I need to take my calculator and I'm going to write this down on a piece of paper. Give me 1 second. 0.004032323. That's a partial year, and we need to change that partial year into days. Let me press clear. 0.0040323. That's the partial year, and we ask ourselves, how many days are there in a year? Just like how we learned in lesson 1 in conversions from standard form to decimal form and vice versa. And we can say that 9 years, approximately is key, approximately 9 years and 1.471 days it will take until the value of the car is 5,000. Let's go on to the last question for this particular problem. During what year does the car become worthless? Now, if something is worthless, we assume it has 0 value. So instead of it having a value of 5,000, we want it to have a value of 0. Now, some of you may prefer to come up here and plug in 0, and we're going to find out where does it cross right here. And others will recognize that I'm just trying to find this x-intercept, also known as a 0. So I can go second trace, and I have a choice right now to do the intersection of where the value's car is 0 along with approximation at any given year or date what the value of the car is. And so I'm going to get close to it and press enter, enter, enter. All right. So when is it worthless? And this particular question says in what year? You could not say in year 12.39. We're actually wanting a year. So I'm going to write this down, 12.39. Give me 1 second. So 12.39 was the intersection for the x value representing the time. And remember that this car was purchased in 1995, and that's our T0. So we can say in the year 2007, we can approximate that the value of the car will be $0.